All right. Okay, let's get into these questions over here, guys. So we know that when we're multiplying over here, we're just going to multiply the numbers. I'm going to get 36 over here, 36. And then I'm going to take whatever has the same base, like bases. And if they're being multiplied, we're going to keep the base x and we're going to add the exponents. I know that x over here has an exponent of 1. So I should get x to the power of 2 plus 1, that's 3. And then I've got y to the power of 3 times y to the power of 4. Those are like bases being multiplied again. So I'm going to keep my base y and I'm going to add my exponents, 7. All right, let's look at this one over here. Now, normally, I know that some of your teachers will say you need to rewrite this thing out 3 times because of that 3 cubed. So you would go 2x cubed times 2x cubed times 2x cubed. We're not going to do that here. We're going to learn a different step. All right, so first thing I'm going to do, anything that doesn't have an exponent gets an exponent of 1. So my 2 is going to get an exponent of 1. And my 3 is going to get an exponent of 1. Now, what I'm going to do is wherever I see a bracket and an exponent, I'm going to multiply my exponents. Same here. I see a bracket and an exponent. I'm going to multiply my exponents. So I'm going to get 2 to the power of 1 times 3. That's 2 to the power of 3. And then x to the power of 3 times 3. That's x to the power of 9 multiplied by... I'm going to do the same over here. I'm going to get 3 to the power of 1 times 2. That's 3 squared. And then x to the power of 2 times 2, x to the power of 4. Then I just have to consolidate the numbers. 2 cubed is 2 times 2 times 2. That's 8. X to the power of 9 times 3 squared is 9. X to the power of 4. Then again, I can just do what I did up top. Multiply my numbers. 8 times 9 is 72. Like bases are being multiplied over here, so I'm going to keep my base x, and I'm going to add my exponents. 9 plus 4 will give me 13. All right, in this last question over here, I'm going to first make that part a little bit easier, and then I still have a bracket and an exponent, so I'm still going to multiply my exponents. But first, let's do our due diligence. At the top here, I'm going to get 6 times 2. I'm sorry, 3 times 2. That's going to give me 6. And then I've got like bases being multiplied. So I'm going to keep my base a and I'm going to add my exponent. So that's going to be 3 plus 5 will give me 8 over 12 to the power of 12a to the power of 10b all squared. Now, I'm going to simplify the thing on the inside before we get started. So 6 divided by 12, that's going to give us a half. Right, a half. Right, and then I'm going to get a, like bases being divided over here. So I'm going to keep my base a. Let me write that a little better. 1 over 2. I'm going to keep my base of a and I'm going to subtract my exponents. But it's very important that I do it in the correct order. I do it in the correct order. So I'm going to do 8 minus 10, which will give me negative 2. Tyler says, won't you put the 2 first, ma'am? You mean this 2 on the outside, this one over here? I'm going to add it in just a little bit, my darling. Don't stress. I'm not going to leave it behind. And then there's a b down here. All right. Now, all of this is to the power of 2. Right. Now, again, everything that doesn't have an exponent gets an exponent of 1. So I'm going to put 1 to the power of 1. I know it sounds stupid, but yeah, I'm going to do it anyway. 2 to the power of 1 and b to the power of 1. Then I know that I've got a bracket and an exponent, so I'm going to distribute that 2 on the outside. Right. So I'm going to get 1 squared a to the power of negative 2 times 2, that's negative 4, over 2 to the power of 1 times 2, that's 2 squared, and b to the power of 1 times 2, that's b squared, right? So that's going to give me 1 squared is just 1 over 2 squared is 4, b to the power of 2. Now, this thing with a negative exponent over here, this thing with a negative exponent cannot be left with a negative exponent. So when it's sitting at the top, I'm going to bring it to the bottom. I'm going to flip it so that it can get a positive exponent. So this then becomes b squared a to the power of 4. Or I can write a to the power of 4 b squared. All right. Okay. And with that, Welcome to the introduction to Exponents grade 10s. I hope everybody is doing great this evening. I'm going to ask before we start, give me a thumbs up if you've done Exponents at school. Give me a thumbs down if you haven't started it yet. Yes, Tyler, what's up? Khulani says, aren't we supposed to write them in order? Example A, B. Yes, you can. It's not going to change my answer. Remember, they're being multiplied to each other. Yes, Khulani? Okay. Yes, we can. Yes, we can. So we could have left it at the bottom, Tyler. We're going to end up with the exact same answer, both you and I. So even if you did this, even if you started by subtracting those two, and then you would have written 1 over 2a squared b. That's what you're saying, yes? If we had written 1 over 2a squared b, you're going to end up with the exact same answer that ma'am's got. Okay, it won't make a difference, my darling. If you do it that way, 100%. It's perfectly fine. All right. The reason why, Tyler, the reason why I did it that way is because what we're about to do next requires us to first subtract and then flip. Okay, and we're going to see that in just a bit. All right. Okay, let's get started on today's lesson, guys. I can see that many of us have already done exponents, so I'm going to try and move a little bit faster through this. All right. Let's start over here. Now, I know that I've got a squared times a to the power 4. Now, what this actually tells me is that my like bases, I do have like bases. I've got an A and an A. They're both like bases. My like bases are being multiplied. Now, when my like bases are being multiplied, what I'm going to do is I'm going to keep the base. What do I do with my exponents, guys? If my like bases are being multiplied, I'm going to keep the base and do what with the exponents? Good, Narisha, that's it, Zaketela. We're going to add exponents. All right, let's keep that in mind as we go along this exercise. All right. Yeah, good. Excellent. All right, we're going to get there. All right, so I know that I've got like bases being multiplied, so I'm going to keep my base of a, and I'm going to add my exponents. 2 plus 4 will give me a to the power 6. All right, now we're going to go over here. You can see I've got 2 and 2. Are my bases the same? I know it sounds like a dumb question. Are my bases the same, guys? Yes, they are. So I'm going to keep my base, and I'm going to add my exponents. 3 plus 5 is equal to 8. And you're going to hear me, guys, you are going to hear me say the word keep the base more times than you would ever like to hear the word keep the base. As a matter of fact, you're going to start dreaming about the word keep the base because Teacher Coco is going to say keep the base so many times. Okay, you're going to dream about it. You'll hear every sentence, keep the base, keep the base, keep the base. Okay, all right. Now, let's look at this next one that we've got over here. I'm sorry, guys. Nightmares. All right, let's look over here. I've got 2 to the power of 3, and I've got 4 to the power of 2. Do I have like bases? Are 2 and 4 the same base? Not at all. But I do know that I can take 4 and I can rewrite it with a base of 2. How else can I write 4? Beautiful, Abu, that's it. We can rewrite 4 as 2 squared. So this 4 can become 2 to the power of 2. Now, do not forget that the 4 itself was already to the power of 2. So what happens over here is we get 2 to the power of 2 to the power of 2 again. All right, because the 4 was already raised to the power of 2. So what I'm going to get is I'm going to get 2 to the power of 3 multiplied by 2 squared to the power of 2. Right, now I know that I have a bracket and an exponent, so I must multiply my exponents. Let's multiply exponents. All right. let's multiply exponents. So I'm going to get 2 to the power of 3 times 2 to the power of 2 times 2 will give me 4. Now, do I have like bases? Do I have like bases? Yes, I do. I've got a 2 and a 2. Those two are like bases. Therefore, I can keep the base and add exponents. 3 plus 4 is 7. Guys, now here's the problem. The reason why ma'am keeps saying keep the base is because I've marked enough papers to know that many of you do this. You say this to me. 2 to the power of 2 times 2 to the power of 3 is equal to 4 to the power of 5. I've been doing this job long enough to know that many of you do this. You go 2 times 2 equals 4, 2 plus 3 equals 5. Is that right? Is that correct? Is it correct? No, not at all. It's not. So when ma'am says keep the base, I want you to dream about it, Narisha, because if you don't remember, then you're going to keep making the same mistake. I've got grade 9s and grade 10s in my class telling me that 2 to the power of 4 divided by 2 to the power of 2 is equal to 1 to the power of 2. That's not right. When we're doing exponents, when we're doing exponents. So people tell me this kind of thing all the time. And that's why I'm always going to remind you guys to keep the base. We need to make sure, guys, we need to make sure. All right, let's look at this next example that we have over there. We'll get to that next one in just a little bit. Let's look at 3 to the power of 5 multiplied by 9 to the power of 3. What is the first thing I notice about these two bases? What do I notice? They're different. Good, Emmanuel, they're not the same. But I know that I can change 9 to have a base of 3. How can I write 9 so that it has a base of 3, guys? Good, Tyler. Wonderful. I can write 3 squared. But 9 was already to the power of 3. So that means I must now take this 3 squared and put it to the power of 3. All right. Do not forget that because the 9 was already to the power of 3. So what I'm going to get is 3 to the power of 5 times, open bracket, 3 squared to the power of 3. All right. Now I'm erasing my 3. Okay, so now I know I've got a bracket and an exponent. So I'm going to multiply my exponents. I'm going to end up with 3 to the power of 5 times 3 to the power of 2 times 3, which is 6. Now, do I have the same base? Yes, I do. So that tells me that my like bases are being multiplied. So I'm going to keep the base and I'm going to add my exponents. 5 plus 6 will give me 11. Give me thumbs up. Everybody's still with me here? Yeah? We're all good, peeps? Beautiful, beautiful, beautiful work, guys. Excellent. Okay, I'm going to ask a dumb question. I give you guys the algebraic expression x plus 1. What is the answer to x plus 1? Thank you. X plus 1 is equal to x plus 1. Why? Tyler, you can. Why is x plus 1 equal to x plus 1? Why can't we add them? Why can't we subtract? Why can't we multiply? Oh, Emmanuel, beautifully said. Because they are not like terms. That's it, Khulani. X and 1 are not like terms. They're not. So we cannot add them. Right. So let's go to this next part that we're about to look at over here. I've got 5 to the power of x multiplied by 5 to the power of 4. First thing we're going to notice is that, do I have the same base? Yes, I do. I have the same base. Like bases are actually being multiplied. But I'm going to keep my base, and then I'm going to add my exponents. What is x plus 4? What is x plus 4? Ivo, Tyler, for X. Ivo. Are they like terms? No, they're not. So it's just going to be X plus 4. All right. It's just going to be 5 to the power of X plus 4. They broke up. All right. Okay, Tyler, be very careful not to multiply, my dear. All right. If they're not like terms, we can't add them. We can't add them. All right. Let's get to the next one. Here we go. Let's start with the base question, the basic question. Do I have like terms or like bases? Do I have like bases? Yes? Do I have like bases? Yes, I do. I've got a 5 and a 5. Like bases are being multiplied. So I'm going to keep my base and then I'm going to add my exponents. So now I have x plus 2. Right. Let's look at my like terms. Let's look over here in my exponents. I know that my like terms are x plus x. X plus x is going to give us 2x. And then we're just going to have a plus 2 joining us because that's not a like term, so we can't add it to anything. I need to do a quick check-in. Give me a thumbs up. Is everybody still with me here? All right, Tyler, my darling, I don't want to leave you behind. Do you want to unmute for me? I want us to do another example together. Do you want to unmute? Are you okay to unmute or no? Okay, all right. Can I put an example on the board? I want you to do it with me. Is that okay? Okay, let's do this. I'm going to say 3 to the power of 2x times 3 to the power of x plus 5. Okay, first thing I'm going to ask Tyler is, do I have like bases? Do I have the same base? Everybody else can answer as well. I'm happy for everyone to answer. Yes, good, we do. So I know I'm going to keep the base of 3. What do I need to do to my exponents? What do I need to do with my exponents? When my like bases are being multiplied, we must add the exponents. So when I add my exponents, I've got 2x plus x plus 5. So we're going to have 2x plus x plus 5. Right. So now I'm going to get 3 to the power of. If we look up top here, what are my two like terms over here? Tyler, what are my two like terms? Good, 2x and x. So Tyler, tell me, what is 2x plus x? Three x. Yes, absolutely. It's 3x. So we're going to get 3x. Now, what must I do with that 5? It must come with me. I can't leave it behind. It must come with. So this then becomes 3x plus 5. Have we got it, my dear? Are you good? Are we all good? All right. Excellent. Good stuff. Let's look at this next example. All right. So over here, I've got another issue. What's my first issue over here? What's my first issue in this question? Correct. The bases are not the same. Well done, Emmanuel. Good. I know that I've got a 7 there, but I've got a 49 there. Which one can I change to look like the other? I can change 49. Good. That's it, Tyler. We can change 49 to 7 squared. Tyler went straight to the answer. He didn't even waste time. Good. So I know that this then becomes 7 squared. Right. So what we're going to have is 7 to the power of 3 times 7 squared. But remember that 49 was already to the power of x plus 1. So now I have to say 7 squared to the power of x plus 1. I now see that I have a bracket and an exponent. What do I need to do with my two exponents here on the inside? What do we need to do with them? We must distribute. We must multiply. Good, Hulani. But now remember that this 2 is multiplying the whole of x plus 1. It's almost like us doing this 2 multiplied by x plus 1. And if we were to multiply this, we would distribute. We would have to distribute, right? So I'm going to end up with 7 to the power of 3 multiplied by 7 to the power of 2 times x will give me 2x, and 2 times 1 will give me positive 2. Good. Now, do I have like bases? Yes, I do. Of course I do. I've got a 7 and a 7. Those are like bases. So I'm going to, what am I going to do, guys? No, Emmanuel, what is step number 1? Before we add exponents, what is step number 1? I told you you're going to dream about it, and I'm going to keep asking about it. Like bases being multiplied, we must what? Princess! Yes! Keep the, guys, keep the base. We're going to write 7. And then after we keep the base, we're going to add the exponents. So now we're going to get 3 plus 2x plus 2. 3 plus 2x plus 2. Emmanuel, do you know that if you went to my school and you were feeling like a bit of a snack and you walked past my classroom door and you peeked your head in and you said, "Ma'am, keep the base," I would give you a sweet. Just by putting your head in my door and going, "Ma'am, keep the base," I would throw you a sweet. I would. And I do that all the time. And my grade 8s and my grade 9s and my grade 10s, they all know. I tell you. All you have to do is walk past my door and say, "Ma'am, keep the base," and I'll give you a sweetie. You might have like drop the location. All right. Fulufelo, sweets all around. Okay, here's a sweet for you, my darling. There, I'm going to give you a sweet. Just for Fulufelo. This one belongs to Fulufelo. Well done, my darling. Keep the base. Okay, let's finish up here, guys. So we must keep our base. We're going to keep the base over here, and we're going to add our exponents. Now, when we add our exponents, we must look for like terms. Now, my like terms are 3 and 2. And I know that 3 and 2 is going to give me 5. So I'm going to get 7 to the power of 2x plus 5. Okay, thumbs up. Is everybody with ma'am here? Are we all good? How are we doing, peeps? Excellent. Good stuff. Okay, Tyler, that's okay, my darling. You and I can take it as slow as we need. All right. If anybody's still confused, guys, don't just put a thumbs up. If you're like, "No, ma'am, thumbs down. Explain again." I will explain again. Okay, it is my job to explain again. So if you're not with me, put a thumbs down. I'm happy to explain again. All right. Beautiful. Let's look at this next one over here. Now, in this next question, we're going to have issues. Do I have same base? Do I have the same base anywhere? Nope. No same bases. I don't have same bases over here. Now, the problem that I'm going to have is finding out what 18 is and finding out what 36 is. Those are rough things. So I want everybody, wherever you are, pick up your scientific calculator. Okay. Well, it isn't, because 18 is not 6 squared, Tyler. 36 is 6 squared, but what about 18? 18 isn't anything squared. Okay, so that's going to be a problem. So here's what you're going to do, guys. On your scientific calculator, you're going to go and you're going to put into your calculator 18 and then click equals, like the normal equals sign. And then you're going to click shift. And then you're going to go look for a button that has the word fact on the top, just like that. So you're going to click 18 equals shift fact. Beautiful, Emmanuel. And it's going to find us the prime factors. Tell me what your calculator says. Abu's already got the answer for me there. Okay, the button with fact on it is like a button like this, and it's got like a dot, a dot, a dot, and then a comma, something like that. Good, princess. That's it. So now we know, I think you can, Narisha. I think you can. Please check for me. Tyler, which calculator do you have? The Casio. The Casio should allow you to do it, my darling. Okay, so I know that on your calculator, there's two different types of equal signs. Okay, there's one in pink that looks like that. Like there's an equal sign in pink. Don't click that one. I don't want that one. Click the normal equal sign. So you're going to type in 18 equals, then click the shift button and look for a button that says fact. It should give you what you need. Yoo, Fulafellow's already far. Well done. Okay, so we're going to take 18 and we're going to write it like our calculator tells us. It says 2 times 3 squared, all to the power of, now remember 18 was already x plus 1, to the power of x plus 1, times, now for 36, we're going to do the exact same thing. We're going to go 36 equals shift fact. And it's going to give us 2 squared times 3 squared, all to the power of 2x minus 1. Now, I just need us to remember, what is the exponent of any number sitting by itself? What is the exponent of this 2 that we've got going over here? Good, the exponent is 1. Beautiful. So I know that I've got an exponent of 1. Now, remember, guys, if I had said to you, I've got AB squared to the power of 3, I know that if A has an exponent of 1, I need to distribute like that. I must go 3 times 1, 3 times 2. Both of them must have that thing multiplied with them. All right, which means for this one over here, we're going to get 2 to the power of, now we're going to take this 1 and we're going to multiply it with the whole of x plus 1. So we're going to go 2 to the power of, this is going to become 1 times x will give me x, and 1 times 1 will give me positive 1, times 3 to the power of. Now if we do the 3 parts, I'm going to get 2 times x, and now I've erased the 1, and 2 times 1. So that's going to give me 3 to the power of 2 times x is 2x plus 2 to the power of 1. Oh, 2 times 1 will give me 2. All right, give me a thumbs up. Does everybody understand what ma'am has done here? Are we all good? Thank you, Theo. Beautiful. I want everybody else to keep up with me. I don't want to leave anyone behind. Excellent, Fulufelo. That's it, Emmanuel. Excellent. Eric, how are we doing? Tristan, are we good? LJ? I hope we're all keeping up, guys. Okay. Remember, you can ask as many questions as you like. I just want to make sure that you guys are okay. Otherwise, there's no point to what we're doing here. All right. Beautiful stuff, guys. Okay, let's go to the next bracket. Okay, that's going to be multiplied by, let's do this part over here. We're going to have 2 multiplied by, right. So I've got 2 to the power of 2 times 2x will give me 4x. 2 times -1 will give me -2 times 3 to the power of, now we're going to do the exact same thing with the 3's, with 3 to the power of multiply. That's going to give me 3 to the power of 4x minus 2. All right. Now, do we have like bases? Do we have like bases? Yes, we do. It just so happens that we have 2 different bases. But it's okay for us to have 2 different bases. We're just going to compare like with like. We're just going to compare like with like. So I've got 2 to the power of x plus 1 times 2 to the power of 4x minus 2. Now, like bases are being multiplied. What do I need to do, grade 10s? What do I need to do? Yes, Emmanuel! Yay! A sweet for Emmanuel. Woo-hoo! A sweet for Emmanuel. Keep the base. That's it. We're going to keep the base of 2. And then we're going to add the exponents. Right, so I'm going to get x plus 1 plus 4x minus 2. I know, Tanyiko, it does happen. Times, I know. And you shouldn't. You should do rational exponents right at the end. It's quite a disconnecting idea. So maybe you should do that at the end. All right. Just give me 1 second. Before we continue. All right, guys, please keep the base for 3 and add exponents for me and pop your answer in the chat. Please keep the base here and add exponents for me. All right, sure. Princess has already gotten to the end of the answer. Well done. All right, let's look. Over here, like bases are being multiplied. So I'm going to keep the base and I'm going to add my exponent. So I'm going to get 2x plus 2 plus 4x minus 2. And then this is just a matter of adding like terms. We're just going to add like terms. All right. Okay, and that's going to give me 2 to the power of, I've got x plus 4x. That's going to give me 5x. And then I've got plus 1 minus 2. That's going to give me -1. Times 3 to the power of, now I've got 2x plus 4x will give me 6x. And then 2 minus 2 will give me 0, so I don't have to write that one. And Fulufelo, beautiful work. Emmanuel, beautiful work. Princess, beautiful work. One of you gave me the answer before I'd even finished. Emmanuel had finished the answer a long time ago. Long time ago. Well done, guys. Well done. Nice one. All right, let's talk about this part over here. Now, I understand over here that my like bases are no longer being multiplied, right? My like bases are being divided. So I'm going to say like bases being divided. I'm going to keep the base. Thank you, Abu. A sweet for you. Keep the base. A sweet for Abu, everybody. Beautiful. We're going to keep the base, but instead of adding exponents this time, I'm going to subtract exponents. Good, subtract the exponents. Now, I'm going to add a caveat to this. All right, caveat means I'm going to add something extra that we must remember. Okay. I'm going to say, when we subtract our exponents, we always subtract top minus bottom. Top minus bottom. I'm going to ask you guys to put this in the chat for me. When I subtract my exponents, how do I subtract? Top minus bottom. Okay, do not forget that, guys. It's very important that we remember when we're subtracting top minus bottom. Good, Zeketela. Good, Theo. That's it. Top minus bottom. And it's going to come into play in just a little bit. All right. Now, over here, I've got like bases. So I'm going to keep my base of 5. And then I'm going to subtract my exponents. But I'm going to take the top. So 2x plus 1 minus the bottom, which is 2x. Would that mean that in some instances it would be an exponent that's a negative? Yes, correct, Amina. And it's perfectly fine for the exponent to be negative. We can deal with it at the end. After we've added and subtracted like terms and the such, then we can deal with it. All right, so watch what's going to happen in the next question as we go through it. All right, now I'm going to simplify my exponents. I'm going to get 5 to the power of 2x minus 2x will give me 0. Good. And then I'm just going to have 5 to the power of 1 left, which is just going to be 5 to the power of 1. Oh, 5 to the power of 1, which is just 5. All right. Okay, let's do the next one. Let's do this one over here. Okay, do I have like bases in this next question over here? Do I have like bases? Yes, we do. Good, we do. So I'm going to keep the base and I'm going to subtract my exponents. How do I subtract exponents, guys? How do I subtract? Good, Abu. Beautiful. Top minus bottom. Now, I want you guys to watch very carefully what I'm about to do. I'm going to go x plus 5 minus, and then in brackets, I'm going to write x plus 2. Okay, and I know many of you are going to be like, ma'am, is the brackets necessary? Absolutely. 100% the brackets are necessary. We do not let go of the brackets, guys. Okay. Excuse me, guys. The change of weather around here is not doing me so great. Okay, so now I'm going to distribute that negative in. I'm going to get 2 to the power of x plus 5. And what I'm now going to do is I'm going to take this negative here and I'm going to distribute it in. I'm going to get negative times x and negative times positive 2. So now negative times x will give me negative x and negative times 2 will give me negative 2. Good, that's it, Zeketela, beautiful. Right, and then we're going to get 2 to the power of. Now, x minus x is going to give me 0, but 5 minus 2 will give me 2 to the power of 3, which is just the same as 2 to the power of 3 is 8. Okay, and that's the final answer we're going to get, 8. Give me a thumbs up. Does everybody see what ma'am's done here? Because it's a very important concept. Good, excellent, guys. Good work. All right, let's get to the next example. Okay, what do I notice about this example here? What do I see? What's wrong? Yes, Emmanuel, that's it. We don't have like bases. But luckily for us, our calculator can do the things for us. We can go 16 equals shift fact. Tommy, what does my calculator say? Oh, Abu, that's not what my calculator is going to say. It's not going to say 4 squared. What is my calculator going to say, guys? 16 equals shift fact? Good, Seketela. It's going to say 2 to the power of 4. And Narisha, if your calculator can't do it, unfortunately for you, you're going to have to go back to prime factorization. Remember from grade grade 8, where you have to do the ladder method. You have to go 16, divided by 2 is 8, divided by 2 is 4, divided by 2 is 2, divided by 2 is 1. Then 2 times 2 times 2 times 2 is the same as 2 to the power 4. You're going to have to do this if your calculator can't do it. I know. So maybe speak to mom or dad or whoever's at home and see if they can't spare like an extra 300 rand nyana to get you the white calculator. Okay, it really does help. It really does help. Yo, Abu, I don't know how you do it. Even me, I gave up on IT when I was in school. All right, so we know that 16 can be written as 2 to the power of 4, but remember that 2 to the power of 4 is still to the exponent of p minus 3. Okay, over, how else can we write 8, guys? That's it, Zeketela. Well done, Emmanuel. So I'm going to open brackets 2 to the power of 3, all to the power of p minus 4. Now I see a bracket and an exponent, a bracket and an exponent. What do I need to do there? What do I need to do? Multiply in. Good. But remember, each of them needs to be multiplied. So 4 times p, 4 times minus 3. 3 times p, 3 times minus 4. Okay. So at the top there, I'm going to get 2 to the power of 4 times p is 4p. 4 times negative 3 will give me negative 12 over 2 to the power of 3 times p is 3p. 3 times negative 4 is negative 12. All right. Now, herein comes the interesting part. All right. Do I now have like bases? Yes, I do. Yes, I do. Well done, Theo. I've got a 2 and a 2. So like bases are being divided. I'm going to keep the base. Good, Fulufelo, beautiful. And then we're going to minus top minus bottom. And Zeketela, a sweet for you, my darling. A sweetie for Zeketela for remembering to keep the base. Well done. All right, so now I'm going to do this. I'm going to go from the top. I'm going to go 4p minus 12 minus bracket 3p minus 12. And this is why the brackets are important, guys. I'm going to go 2 to the power of 4p minus 12. Now, if I distribute this negative in, negative times 3p, negative times negative 12. Negative times 3p will give me negative 3p, but negative times negative 12 is going to give me what? Positive 12, that's it. So plus 12. So do you see why those brackets are very, very important? Because if we forget to put the brackets around there, the thing that should turn positive is going to stay negative and your answer is going to come out wrong. So we need to make sure that we keep that bracket in there and then distribute the negative before we do the other calculations. All right. Now we can add like terms. 2 to the power of. I'm going to get 4p minus 3p. That's just going to give me p or 1p. Doesn't make a difference, right? And then I'm going to get negative 12 plus 12, which will give me 0. So my final answer is 2 to the power of p. How are we feeling, guys? Good? Meh? Yo, ma'am, come again. How are we feeling? Feels hundreds. I love it. Excellent stuff, guys. It's okay for us to be confused. It's okay for you to be confused. The point is to not give up. Keep trying. It gets easier. It really does. All right. It really does get easier. The more you do it, the easier it becomes. All right, let's look at this next question that's coming up. All right. Okay. Now we already know. No, Abu, no. You always talk a big game in the chat. Now all of a sudden, bye, I quit. No, ma'am. No. I don't accept. I don't accept. Good. We know that we can go to our calculator and we can go 50 equals shift fact. We can do 50 equals shift fact. Right. And Abu's already got the answer for us on the top. He says that 50 can prime factorize into bracket 2 times 5 squared. But all of that was already to the power of x plus 1. What is the exponent of this 2 over here, guys? What is the exponent of the 2? It's 1. Good. There's a 1 over here. Right. Good. Then we're going to go to the bottom and we're going to have 2 to the power of x plus 1 times, how else can we write 25? Good. That's it. 5 squared. So I'm going to open brackets and I'm going to go 5 squared to the power of x plus 1. Now remember, guys, if the number on the top has more than 1, each of them needs to be multiplied. So 1 needs to be multiplied by x plus 2, and 2 over here must be multiplied by x plus 1. Sorry, not x plus 2, x plus 1. So we need to take it a step at a time. All right, let's start at the top. We're going to get 2 to the power of 1 times x plus 1 will just give us x plus 1. 2 to the power of x plus 1 times 5 to the power of, now if we distribute 2 times x, 2 times 1, that's going to give me 5 to the power of 2x plus 2 over, ooh, that was the worst line Mem has ever drawn. Sure, no judgment, guys, no judgment. Over 2 to the power of x plus 1 multiplied by 5 to the power of, let's distribute down here, 2 times x, 2 times 1, that's going to give me 2 times 2x plus 2. Now, let me ask a series of really basic, stupid questions. All right, I'm going to ask some stupid questions. Okay, I'm going to ask, what is 3 divided by 3? Correct, Abu. Well done. What is 3 divided by 3, guys? Good, Ziketa, it's 1. I'm not asking a very dangerous question here. What is 5 divided by 5? It's 1, right? What is x divided by x? 1. It's all going to be 1, right? So let me extend this to exponents. What is 2 divided by, 2 to the power of x divided by 2 to the power of x? 1. It's also 1. Now, I want us to take this exact idea that we're looking at. Look at the answer we've been given down here. What do we notice about these two? 2 to the power of x plus 1 divided by 2 to the power of x plus 1 will give me what? 1 times 5 to the power of 2x plus 2 divided by 5 to the power of 2x plus 2, 1. So now I've got 1 times 1, which means my answer is indeed just 1. Thumbs up, thumbs down. How are we feeling? We all okay? I almost went into retirement. Oh, ever the dramatic Abu. Good, Narisha. I love it. I love it. And I want you to take that confidence and I want you to translate it into this question that we've got on the screen now. All right. It's okay, princess. I want you to try this one. It's not as difficult as it seems. Okay. Give this one a try, guys. I want you guys to tell me what you come up with. Okay. Or pop your favorite emoji in the chat when you're ready. Okay, I'm going to give you guys about 3 minutes. Otherwise, we're going to run out of time for the lesson. Okay. Phew, you guys are super fast. And for those of you who aren't quite done, that's okay. That's okay. We're going to get into this question over here real quick. All right. So let's start at the top. I've got an 18 to the power of x. I have no like bases anyway. So I'm going to have to figure out how to get to like bases. I know that 18 is the same as 2 times 3 squared to the power of x. Before I even forget, I'm going to put a 1 there. I don't want to forget to distribute. Right, multiplied by, I know 8 can be written as 2 to the power of 3, all to the power of x minus 1, over 9 is also going to be 3 squared to the power of x plus 1, times 4 can be written as 2 squared to the power of 2x minus 1. Now, all it is a matter of distribution. Let's just get rid of the brackets. All right, so we're going to start over here. I've got 1 times x, 2 times x. So I'm going to end up with 2 to the power of x times 3 to the power of 2 times x will give me 2x multiplied by 2. I almost wrote 3. 2 to the power of, let's distribute, guys. 3 times x, 3 times negative 1. 3 times x will give me 3x minus 3 over, at the bottom, I'm going to get 3 to the power of, distribute, 2 times x will give me 2x, plus 2 times 1 will give me 2, multiplied by 2 to the power of 2 times 2x is 4x, and 2 times negative 1 is negative 2. All right, this is equal to, now what I'm going to notice on the top is that I've got like bases being multiplied. I have like bases being multiplied, so I'm going to keep my base of 2, and I'm going to add my exponents. Now, x plus 3x will give me 4x, and then there's a minus 3 that comes with it. And then over here, I've still got times 3 to the power of 2x at the top, over 3 to the power of 2x plus 2 times 2 to the power of 4x minus 2. Right, now my like bases are being divided. So I'm going to keep the base. I'm going to start with 3. I'm going to go 3 to the power of, how do I subtract my exponents? Top minus bottom. So I'm going to get 2x minus, open bracket, 2x plus 2 times 2 to the power of top 4x minus 3 minus, open brackets, 4x minus 2. And then we're going to distribute that negative, guys. So I'm going to get 3x to the power of 2 to 3 to the power of 2x. Distribute negative times 2x will give us negative 2x. Negative times 2 is minus 2 times 2 to the power of 4x minus 3. Distribute minus 4x, and negative times negative 2 will give me plus 2. That is equal to, now, 2x minus 2x will cancel. And 4x minus 4x will also cancel. So what I've got over here is 3 to the power of negative 2 times 2 to the power of, I've now got negative 3 plus 1, that is negative 1. 2 to the power of negative 1. Now, both my numbers are negative exponents. So I now need to flip both of them. I'm going to put them both over a fraction, and I'm going to put 1 over, and at the bottom, I'm going to get 3 squared times 2 to the power of 1. And I can work that out. 1 over 3 squared is 9 times 2 is 18. Thumbs up. How did we do?